Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Let me know in the chats with some fire emojis quick. If all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly let me know in the chats with some fire emojis. Everybody. Welcome back, welcome back, welcome back, people. Welcome back. Welcome back. So, my dear students, as you all must be knowing, we have started the top 50 concept series in all the subjects. And already I have taken one session in the top 50 concepts, wherein I have already taught you some 9 to 10 concepts. So, again, in the today's session, I'll be teaching you the short 10 concepts of your chemistry. 10 concepts means 40 marks for sure from this particular session. Okay? So are you all ready? Are you all ready? Let me know quickly in the chats, everybody. Are you all ready? Quickly in the chats. Everyone. All right, amazing. So before starting this particular session, can you let me know in the chats how many of you watched this session 1? Say yes or no in the chats. How many of you are done with session 1 of this particular series, which I took, I think, 3-4 days back? Just let me know in the chats. Just let me know in the chats. Say yes or no in the chats. I just want to know first of all. All right, all right. All right, people. Perfect. So without wasting a lot of our time then, let's get going, let's get started. And try to complete 10 more important concepts, 10 more short concepts which will be asked in your NEET 2025 for sure. Okay? Perfect. So people, the first concept which we are going to discuss in the today's session, from which questions are, I would say, every year asked. What is that? That's your valence shell electron pair repulsion theory, VSEPR. That's your VSEPR, valence shell electron pair repulsion theory. Before starting this session, let me tell you the PDF of this particular session, the handwritten PDF of this particular session, I'll be sharing on my Telegram. If you are not the part of my Telegram channel, be the part of my Telegram channel quick. The name of the Telegram channel is Wassim Bhat Chemistry Official. Okay? Wassim Bhat Chemistry Official is the name of the Telegram channel on which I keep on sharing the handwritten PDFs of every sessions. Okay? So people, this is the super important thing from which questions will be every year asked basically when it comes to the NEET examination. Okay? And this particular theory, you know, it is from the chapter chemical bonding, your inorganic chemistry, right? So, if I first of all talk about the valence shell electron pair repulsion theory, if I talk about your valence shell electron pair repulsion theory, from this particular theory, what kind of questions are asked? If you ask me, what kind of questions will be asked from this theory? My dear students, from this particular theory, the question will be directly asked related to the shape of the molecules. You'll be given with a molecule. You'll be given with a molecule and you will be supposed to check the actual shape of the molecule. And let me tell you, the actual shape of the molecule can be checked with the help of your valence shell electron pair repulsion theory. Okay? The second question which can be asked here, what is that exactly? My dear students, the second question that can be asked, you will be asked to calculate the number of bond pairs and the number of lone pairs. From this particular thing also, a question will be asked. Okay? Calculation of your bond pairs, calculation of your lone pairs. Sometimes you will be asked to check the type of the molecule. Sometimes you'll be asked to check the type of the molecule. All those things I'll be discussing here in this particular valence shell electron pair repulsion theory. Okay? Now, before discussing the shape of the molecule, before checking the bond pairs, lone pairs, let me first of all teach you some basic stuff. Some basic stuff I'm going to teach you. And from that basic stuff, we can, check the shapes of different molecules which are frequently asked. Check, people, what I'll be doing. Understand what I'll be doing. Understand properly, okay? Understand properly. Just give me a second. Just give me a second. Okay, understand properly. First thing, how do we check the type of the molecule? This is the first thing. How do we check the type of the molecule? This is the first thing. And if you got to know how to check the type of the molecule, you can easily talk about the shape of the molecule as well. Okay? In order to get the shape of the molecule, we should know the type of the molecule first of all. And let me first of all give some 5 to 10 minutes to make you understand how to identify, how to check the type of the molecule. For example, if I take the example as CH4, this is your molecule, CH4. My dear students, in case of CH4, if I ask you, which one is your central atom? Your carbon is your central atom here. Okay. Now, in case of carbon, if I ask you, how many valence electrons are there? You know, in case of carbon, there are 4 valence electrons. Absolutely. Now, if I ask you, how many surrounding atoms are there? There are 4 surrounding atoms. There are 4 surrounding atoms, right? Remember, the number of surrounding atoms is equal to the number of sigma bonds. The number of surrounding atoms is equal to the number of sigma bonds, right? That means this carbon is forming 4 sigma bonds. Perfect. Now, if you look carefully, my dear students, carbon had 4 valence electrons. Carbon had 4 valence electrons. Carbon had 4 valence electrons. And carbon is forming 4 sigma bonds. Carbon is forming 4 sigma bonds. Carbon had 4 valence electrons and it's forming 4 sigma bonds. Can I say, since carbon had 4 valence electrons, can I say carbon is utilizing all these valence electrons to form sigma bonds? It had 4 valence electrons, forming 4 sigma bonds with the help of these 4 valence electrons. I would say if carbon had 4 valence electrons, it is forming 4 sigma bonds. So what does that mean? That means carbon is utilizing all its valence electrons to form 4 sigma bonds. Okay. If carbon is utilizing all its valence electrons to form 4 sigma bonds, if I ask you, how many lone pairs will be there on carbon? There will be no lone pair. So, 4 sigma bonds, 0 lone pairs. If I ask you what is going to be the type of the molecule, the type of the molecule you'll write like this. A is your central atom, for example, which is your carbon here, right? How many sigma bonds it's forming? 4. So, I'll write B4. How many lone pairs central atom has? Central atom has 0 lone pairs. So, the type of the molecule here is simply going to be AB4L0. This is how you check the type of the molecule. I'm just talking about the type of the molecule right now. Okay. Let me take few more examples. For example, you have got something like this. NH4 positive. Let's say you have got NH4 positive. My dear students, in case of NH4 positive, if I ask you, which is your central atom? Nitrogen. How many valence electrons nitrogen has? Nitrogen normally has 5 valence electrons, but there is a positive charge. There is a positive charge. If there is a positive charge, subtract. So I'll subtract 1 unit from it. So I'll be getting 4. So there are 4 valence electrons with nitrogen right now. How many surrounding atoms are there? There are 4 surrounding atoms. 4 surrounding atoms means there are 4 sigma bonds. Okay. So since nitrogen had 4 valence electrons, it is forming 4 sigma bonds. That means nitrogen has utilized all its 4 valence electrons to form 4 sigma bonds. So will there be any lone pair on nitrogen? There will be no lone pair on nitrogen. Perfect. If I ask you what is the type of the molecule, the type of the molecule here also is going to be AB4L0. It's going to be AB4L0. My dear students, for example, you have got a molecule like this, SF4. Okay, SF4. Which one is your central atom here? Sulfur is your central atom. How many valence electrons sulfur has? Sulfur has 6 valence electrons. How many surrounding atoms it has? 4 surrounding atoms. That means 4 sigma bonds. I'll say sulfur has 6 valence electrons and it's forming 4 sigma bonds. That means sulfur has utilized 4 of its valence electrons to form 4 sigma bonds. Sulfur has utilized 4 of its valence electrons to form 4 sigma bonds. So can I say there will be 2 electrons left as such on sulfur in the form of a lone pair? So there will be 1 lone pair on sulfur, right? Now, if I ask you what will be the type of the molecule, pretty much simple. The type of the molecule is going to be AB4L1. This is the type of the molecule, right? For example, here you might do a mistake. For example, I'm talking about carbon dioxide. Just give me a second, guys. Just give me a second. Just a second, guys. Just a second, guys. Okay. So I'm talking about carbon dioxide. Perfect. Now, first of all, in case of carbon dioxide, which one is your central atom? Carbon. So how many valence electrons carbon has? 4. How many surrounding atoms are there? There are 2 surrounding atoms. That means carbon is forming 2 sigma bonds. Correct? Carbon is forming 2 sigma bonds. Right? Now, my dear students, you know oxygen is divalent. Oxygen is divalent. If you have got a divalent atom attached, okay, consider, just to make you understand, just so that you can remember it. Consider that these 2 divalent atoms, they are forming 2 bonds with carbon. So carbon had 4 valence electrons. Now consider as if one oxygen is forming 2 bonds with carbon, right? So carbon in total is forming here 4 bonds. So 4 valence electrons carbon had, sigma bonds 2, right? And these are divalent atoms attached. Perfect. So can I say all the 4 valence electrons which carbon had, it has utilized them? And if it has utilized them, that means how many lone pairs will be there on carbon? 0 lone pairs. So type of the molecule here is going to be AB2L0. So remember, whenever you have got a divalent atom attached here, this is how you check it. I'll give you one more example. So that it will be properly clear to you. My dear students, for example, you have got XeOF4. Understand what I'll be doing. Central atom here is xenon. Xenon has 8 valence electrons, right? How many surrounding atoms are here? 5. 4 plus 1, 5. So sigma bonds 5. So now I have to check lone pairs. See, xenon had 8 valence electrons, right? Now, oxygen here is divalent. So consider 2 bonds. Plus 1 fluorine means 1 bond. 4 fluorine means 4 bonds. So 4 plus 2 makes it 6. So imagine as if xenon is forming 6 bonds. So xenon is utilizing 6 valence electrons. So I would say 2 valence electrons will be there on xenon in the form of 1 lone pair. Right? So what would be the type of the molecule now? It will be AB5L1 type. I hope you're understanding what I'm trying to say. For example, you have got a molecule like this, XeO2F2. XeO2F2. Xenon. How many valence electrons? 8. How many surrounding atoms? 2 plus 2, 4. So 4 sigma bonds. Right? See, oxygen, there are 2 oxygen atoms. So you'll consider 4 bonds. Right? 4 plus 2 makes it 6. So out of 8 valence electrons, 6 are utilized. So xenon will be having 2 valence electrons in the form of 1 lone pair. So type of the molecule is going to be AB4L1 type. Perfect. So I hope you got to know how to identify the type of the molecule. Perfect. For example, you have got something like this. NO2 negative. Nitrogen being the central atom. How many valence electrons? Nitrogen has 5. There's a negative charge. So add it. 5 plus 1, 6. Surrounding atoms are 2. That means 2 sigma bonds. Oxygen is divalent. So would you consider 2 bonds here or 4? You'll be considering 4. So nitrogen had 6 valence electrons. 4 are being utilized. you can say 2 valence electrons will be left as such in the form of one lone pair. So type of the molecule is simply going to be AB2L1. Right? So is this clear? Did you get to know how to check the type of the molecule? Say yes or no once in the chats quick. Quickly, guys. Everyone in the chats quick. Everybody quick. All clear? All clear, people? And once you get to know how to check the type of the molecule, you can easily talk about the shape of the molecule. How exactly? That's something which I'll be telling you now. So let me give you a few more examples. 1-2 more examples so that it will be like properly clear to you. For example, I've got the molecule PCl5. This is one of the molecule which I have. For example, I've got the molecule SF6. One more molecule I have. For example, I have got the molecule, let's say, NH3. These are few molecules which I have. Now let's check their type. Let's check their type. Phosphorus is a central atom, 5 valence electrons. Surrounding atoms are 5, so 5 sigma bonds. If phosphorus had 5 valence electrons, I would say it is utilizing all the 5 to form 5 sigma bonds. So there will be no lone pair. So the type of the molecule simply is going to be AB5L0. Simple. Now talk about this one, SF6. Sulfur here again is a central atom. So how many valence electrons? 6. How many sigma bonds it's forming? 6 sigma bonds, right? How many lone pairs will be there on sulfur? 0. Type of the molecule is going to be AB6L0. Correct? Talk about NH3. Nitrogen is the central atom. How many valence electrons? 5. How many sigma bonds? 3. Out of 5 valence electrons, 3 valence electrons are utilized. So I would say 2 valence electrons will be there in the form of one lone pair. So type of the molecule is simply going to be AB3L1. Am I clear? Now am I clear? Now am I clear? Now am I clear? Everybody in the chats quick. Say yes or no. Say yes or no quickly, people. Everybody. Everybody in the chats. Perfect. Perfect. Now, once you get to know how to check the type of the molecule, since you got to know that, now you can easily talk about the shape of the molecule. How do we get to know the shapes of the molecule? See, guys, understand and remember. Understand and remember. First of all, whenever you see a molecule of the type AB2L0, whenever you see a molecule of the type AB2L0, okay, remember its shape is going to be linear. It is going to be linear. Number 1. Number 2, whenever you see a molecule of the type AB3L0, it's going to be trigonal planar. It's going to be trigonal planar. AB3L0 type. Okay. Whenever you see a molecule of the type AB4L0, right? AB4L0, remember the shape of the molecule is going to be tetrahedral. Simple. It's going to be tetrahedral. You have to remember all of this. Okay, you have to remember all of this. Now, my dear students, whenever you see a molecule of the type AB3L1, remember the shape of the molecule is going to be pyramidal, trigonal pyramidal. Okay, it's going to be pyramidal in shape. Similarly, whenever you see a molecule of the type AB2L2, the molecule is going to be bent shaped. It is going to be bent shaped. You have to remember all of this. You have to remember all of this. Whenever you see a molecule of the type AB5L0, AB5L0, the shape of the molecule is going to be trigonal bipyramidal. Trigonal bipyramidal. Whenever you see a molecule of the type AB4L1, the molecule is going to be of seesaw shaped. The molecule has got the shape seesaw. Okay, the molecule has got the shape seesaw. Similarly, whenever you have got the molecule of the type AB3L2, AB3L2, the molecule is going to be T-shaped. The molecule is going to be T-shaped. Okay. Whenever you have got the molecule AB2L3, AB2L3, the molecule is going to be linear. The molecule is going to be linear. Whenever you have the molecule of the type AB6L0, the molecule is going to be octahedral in shape. Octahedral in shape. Whenever you see a molecule of the type AB5L1, the molecule is going to be square pyramidal in shape. Square pyramidal. Square pyramidal in shape. Okay, square pyramidal in shape. Whenever you see a molecule of the type AB4L2, AB4L2, can you tell me what is going to be the shape of this molecule? Quickly. It is going to be square planar. The molecule is going to be of the type square planar, right? Similarly, whenever you see a molecule of the type AB7L0, AB7L0, its shape is going to be pentagonal bipyramidal. Pentagonal bipyramidal. And whenever you see a molecule of the type AB6L1, it is going to be distorted. What is it going to be? Can you let me know in the chats? AB6L1. AB6L1. Quick in the chats. Yes. Distorted octahedral. Okay. These are the things which you have to remember. These are the things which you have to remember. Okay. These are the things which you are supposed to remember. And if you remember these things, now tell me the shape of all these molecules whose type we have already checked. This molecule is of the type AB4L0. So it's going to be tetrahedral. AB4L0, tetrahedral. AB4L1, seesaw shaped. Right? AB2L0, linear. AB5L1, AB5L1, square pyramidal. Okay, AB4L1, seesaw shaped. Right? Seesaw shaped. Perfect. Am I clear, guys? Someone is saying, what about I3 negative? Someone is saying, what about I3 negative? If I talk about I3 negative, my dear students, I3 negative, you can write it as I2 negative. I3 negative, you can write it as I2 negative, right? Okay. Now, my dear students, consider this as a central atom. So, how many valence electrons? 7. There is a negative charge, so 7 plus 1 makes it 8. How many sigma bonds? There are 2 sigma bonds. Out of 8 valence electrons, 2 are utilized to form 2 sigma bonds. So, 6 electrons are left as such in the form of 3 lone pairs. So, there are 3 lone pairs. So, the type of the molecule is going to be AB2L3. AB2L3 means linear. Right? AB2L3 means linear. Am I clear? Am I clear, people? Is this particular topic clear to everyone? So if a question is asked from this particular concept, you should be in a position to solve the question. I hope I'm very clear to you. Okay? Sir, how many marks this session contains? This session contains 40 marks. Okay, honestly, I'm telling you. This particular session carries 40 marks, guys. All right. Perfectly clear? I'm not able to check your chats, guys. Just let me check it from your phone. AB2L1 means bent only. AB2L1 means bent shaped only, okay? So I hope all these questions, right? This, if a question is asked from this particular concept, you should be in a position to solve each and every question from it. This was our concept number one. This was our concept number one. Okay? This was our concept number one. Now, my dear students, can you tell me the answer of this question in the chats quickly? In the structure of ClF3, the number of lone pair of electrons on the central atom. This is the central atom. How many lone pair of electrons are there? Quickly, everyone. It's pretty much simple. Again, how many valence electrons chlorine has? 7. How many sigma bonds it's forming? 3. So how many lone pairs will be there? Out of 7, 3 are used. So 4 will be there in the form of 2 lone pairs, right? So there are 2 lone pairs, right, on chlorine. Correct? Correct, people? Correct? So there are 2 lone pairs on chlorine. Okay. Tell me the answer of this question. Everybody, quick. XEF4. 4 sigma bonds, 2 lone pairs. 4 sigma bonds, 2 lone pairs. Right? 4 sigma bonds, 2 lone pairs. Square planar. Square planar. 6 sigma bonds, 1 lone pair. Distorted octahedron. So check if you find any option from this. A, you are matching with 2. A, you are matching with 2. Similarly, B, you are matching already with 3. Now you can check your C and D. Right? So I think you can easily solve it now. Yes? Perfect. So the correct option is going to be option B. The correct option is going to be option B. Let's move on to the second concept, that is characteristics of equilibrium constant. This is again one concept from which questions are asked. Okay? I hope the first concept is very much clear to every one of you. Moving on to concept number 2. Concept number 2, that is characteristics of equilibrium constant. My dear students, there are few things which I would want you guys to remember. Okay? There are few things which I would want you guys to remember. And from those things, you can easily solve a question which will be based on characteristics of equilibrium constant. Try to understand what I'll be saying. Try to understand what I'll be saying. My dear students, for example, you have got a reaction like this. A in equilibrium with B. This is your reaction. People, let the equilibrium constant of this particular reaction is K. Let the equilibrium constant of this particular reaction is equal to K. Okay, this is the equilibrium constant of the reaction. Perfect. This is the equilibrium constant of the reaction. The first thing, my dear students, if you reverse the reaction, like this, what happens to equilibrium constant? Equilibrium constant is inversed. So the equilibrium constant of this particular reaction will become 1 by K. Equilibrium constant of this particular reaction becomes 1 by K. Okay? Number 1. Number 2, people. If you multiply this reaction by some number, let's say I'm multiplying this reaction by N, it becomes Na in equilibrium with Nb. If I multiply this reaction by some number N, that N goes to the power of equilibrium constant. So I would say the equilibrium constant of this particular reaction is now going to be K raised power N. It's going to be K raised power N. It's going to be K raised power N. Okay? It's going to be K raised power N. Perfect. Now at the same time, one more thing. Let's say you have got the reaction like this, A in equilibrium with B, whose equilibrium constant is, for example, K1. You have got one more reaction, C in equilibrium with D. Its equilibrium constant, for example, is K2. Perfect. Now, for example, if I add these two reactions, what do I get? I'll be getting A plus C gives B plus D. Now, since I've added these two reactions, when you add the two reactions, their equilibrium constants are multiplied. So I would say equilibrium constant of this particular reaction will become K1 multiplied by K2. Okay. These are few things which I would want you guys to remember. That's it. These are few things which I would want every one of you to remember. Okay. Perfect. And if you remember these things, you're sorted. You can solve the questions easily, which are based on the characteristics of equilibrium constant. Okay. So try to understand what I'll be doing. For example, a basic question. A basic question, guys. Try to understand very carefully. As far as the question is concerned, Kp for the reaction that's given to me is N2 plus 3 times H2. It gives 2 times NH3. As per the question, the equilibrium constant of this reaction is 49. Equilibrium constant of this reaction is 49. Now, I am supposed to calculate equilibrium constant for this reaction. I'm supposed to calculate equilibrium constant for this reaction. Remember, the reaction whose equilibrium constant is to be calculated. The reaction whose equilibrium constant is to be calculated, you are supposed to make that reaction out of the given reaction. Again, I'm repeating the same thing. The reaction whose equilibrium constant is to be calculated, you are supposed to make that reaction out of the reaction whose equilibrium constant is given. So basically, from this reaction, I have to make this reaction. Now the point is, how from this reaction, I'm going to make this reaction. The reaction which I have to make, in that reaction, NH3 is on left side. So what do? Let me reverse this reaction first. It becomes 2 times NH3. Gives what? Gives N2 plus 3 times H2. So first of all, I have reversed the reaction. If I have reversed this reaction, its equilibrium constant will be inversed. It will be 1 by 49 now. It will be 1 by 49. Now the reaction which I have to make, its stoichiometric coefficient has to be 1. But here it's 2. So what I'll be doing? I'll be multiplying this reaction throughout by 1 by 2. If I multiply this reaction throughout by 1 by 2, 1 by 2 and 2 gets cancelled. So this becomes NH3. This becomes half of N2 and this becomes 3 by 2 times H2. So what did I do exactly? I multiplied this reaction by 1 by 2. So that 1 by 2 will go to the power of equilibrium constant. So it will become 1 by 49 raised power 1 by 2. The value comes out to be 1 by 7. Right? Now do you see this reaction? Do you see this reaction and this reaction? They are same. Right? So the answer of our question is going to be simply 1 by 7. Am I clear? Am I clear, people? Am I clear? Right? I hope I am perfectly clear to everyone. Moving on to one more. Now, here in this particular question, we are given with 3 reactions. Their equilibrium constants are given. K1, K2 and K3. I have to get the relation between K1, K2 and K3. I have to get the relation between K1, K2 and K3. How you guys are going to do it? How you guys are going to do it? Tell me in the chats quickly. No, sorry, I don't have to get the relation between these. I have to calculate the equilibrium constant for this reaction. I have to calculate equilibrium constant for this particular reaction. Now the reaction whose equilibrium constant is to be calculated, you are supposed to make that reaction out of those reactions whose equilibrium constant is given. Let me call this as reaction number 1. Let me call this as reaction number 2. Let me call this as reaction number 3. Okay. So let me do one thing. Let me write the second reaction as such. N2 plus O2 gives 2 times NO. I have written second reaction as such, whose equilibrium constant is K2. Second reaction I have written as such. Let me do one thing. Let me multiply third reaction by number 3. Let me multiply this reaction by 3. Okay, so that this becomes 3 times H2 plus 3 by 2 times O2 gives 3 times water. Since you have multiplied this reaction by 3, that 3 goes to the power of Vikram constant. So it's K3 raised power 3. Okay, perfect. Let me do one thing. Let me just reverse the first reaction. When I reverse the first reaction, it becomes 2 times NH3. It gives N2 plus 3 times H2. Since I have reversed this reaction, its equilibrium constant now becomes inversed, 1 upon K1. Okay. Now, my dear students, just do one thing. Just add these 3 reactions now. And see what all things will get cancelled out. So when you add these 3 reactions, this 3 times H2, 3 times H2 gets cancelled out, right? This N2 and this N2 gets cancelled out. What am I left with? This is 2 times NH3 plus 3 by 2 O2 plus O2 makes it 5 by 2 O2. 3 by 2 O2 plus O2 makes it what? 5 by 2 O2 gives, on this side, I'm left with 2 times NO plus 3 times water, right? Do you see this reaction? So, just check this reaction and this reaction. Can I say I have made this reaction? How I made this reaction? When I added these 3. And when you add the reactions, their equilibrium constants are to be multiplied. So, what would be the equilibrium constant of this reaction now? It would be K2 multiplied by K3 raised power 3 multiplied by this particular term, which is 1 upon K1. So, this is going to be the equilibrium constant for this particular reaction. Check the options. Check the options, people. So it has to be your option 1. Am I clear to everyone quickly? So I hope these sort of questions you should be in a position to solve. So basically, remember again one thing. The reaction whose equilibrium constant is to be calculated. You're supposed to make that reaction out of the given reactions. That's all. That's all, people. Okay, that's all. All right, and if it is clear, tell me the answer of this question. You are going to tell me the answer of this question. There are 2 reactions given. Their equilibrium constants are K and K dash. K and K dash respectively. You need to tell me the relation between K and K dash. Quickly. Quickly, people. Tell me the relation between K and K dash. What do you think about this question? Basic question and your NEET standard question this is. Everyone in the chats, quickly. Everyone in the chats. I'm not solving this question because it's a similar type of question. It is the similar type of question, guys. What is going to be the answer of this question? Absolutely, it has to be option C. Nothing you have to think about this question. Okay? Nothing you have to think about this question. Perfect? Amazing. Amazing, guys. Amazing. Just a second. Concept number 3. Concept number 3 is our KP and KC calculation. Okay? KP and KC calculation. A lot of students find this particular topic very difficult. A lot of students, they find this particular topic very difficult. So, my dear students, I'll try to simplify this particular topic for you so that if a question comes from this particular topic, you should be in a position to solve that question. So, try to understand properly what I'll be doing. Okay? Try to understand properly what, what I'll be doing. See, first of all, let's say you've got the reaction like this. A gas plus B gas, or let me keep it simple for now. Let's say you've got the reaction A gas in equilibrium with B gas plus C gas. Let's say this is a reaction. This is a reaction. A gas gives B gas plus C gas. My dear students, for example, I have to write the expression of Kc. How do I write the expression of Kc for the reaction? I'll be starting with the product. I'll write concentration of B at equilibrium, raised power stoichiometric coefficient 1. Concentration of C at equilibrium, raised power stoichiometric coefficient 1, divided by concentration of A at equilibrium, raised power stoichiometric coefficient of A, that's 1. Now, my dear students, if I need to write the Kp expression, how do I write the Kp expression? It is going to be, start with the products. You'll write partial pressure of B at equilibrium, raised power stoichiometric coefficient 1, partial pressure of C at equilibrium, raised power stoichiometric coefficient 1, divided by partial pressure of A at equilibrium, raised power stoichiometric coefficient 1. So the point is, whenever I need to calculate the value of Kc, what do I need? I need the concentrations of reactants and products at equilibrium. Whenever I'm supposed to calculate the value of Kp, I need to know the partial pressures of reactants and products at equilibrium. Okay, now see what will I be doing and try to understand properly what I'll be doing. Say guys, for example, at time t is equal to 0. For example, at time t is equal to 0. Let's say I've got A moles of reactants. Let's say I've got A moles of reactant. Since the reaction is not started yet, so B and C has not got formed yet. Now, let me assume at equilibrium, out of A moles of reactant, let's assume X moles got converted into product. At equilibrium, out of A moles of reactant, let's assume X moles got converted into product. So I'll be left with A minus X moles of reactant. Now 1 mole gives 1 mole. So from X, you would have got X. 1 gives 1. From X, you would have got X. So what did I get here? I got the moles of reactants and products at equilibrium. This is always your first step. Calculate the moles of reactants and products at equilibrium. Okay. Now, my dear students, we are done with the calculation of moles of reactants and products at equilibrium. Now, after this, since this particular reaction would be taking place in some container, right? Let the volume of that container be V liters. Since the reaction would be taking place in some container, let volume of that container be V liters. My dear students, when these moles are divided by the reaction, volume of reaction vessel, when these moles are divided by the volume of reaction vessel, what do I get? I get the concentration of reactants and products at equilibrium. So I would say A minus X divided by V. Similarly, X by V. Similarly, this X by V. What are these terms? These are the concentration. This is the concentration of reactant at equilibrium. This is the concentration of B at equilibrium. This is the concentration of C at equilibrium. And why do I need the concentrations of reactants products at equilibrium? Because I have to get the Kc value. So Kc now will be simple. Concentration of B at equilibrium, which is this one, X by V, multiplied by concentration of C at equilibrium, which is again X by V, divided by concentration of A at equilibrium. So our Kc expression will become concentration of B is X by V, concentration of C is X by V. So X square divided by V square, whole divided by concentration of A at equilibrium, which is A minus X divided by V. So V and V gets cancelled. The final value comes out to be X square divided by V multiplied by A minus X. This is the expression of Kc over here. So this is how you calculate Kc value. Get the concentrations of reactants products at equilibrium and finally write the expression for Kc. Now the point is, how do we calculate the Kp expression? My dear students, to calculate Kp, what do I need? I need partial pressures. I need partial pressures of reactants and products at equilibrium. And what is partial pressure? Partial pressure is nothing. It is total pressure of the mixture at equilibrium. Multiplied by mole fraction. For example, I want to calculate partial pressure of A at equilibrium. It would be total pressure of the mixture at equilibrium multiplied by mole fraction of A. Partial pressure of B at equilibrium, that will be total pressure of the mixture at equilibrium multiplied by mole fraction of B. For example, have a look guys. Have a look. Since I've calculated the moles of reactants and products at equilibrium. Now, if I ask you, how many total moles are there in the container at equilibrium? You'll say A minus X plus X plus X. So X gets cancelled out. The value comes out to be A plus X. These are the total moles which are present in the container at equilibrium. These are the total moles present in the container at equilibrium. Now, my dear students, if I divide A minus X with A plus X, if I divide this X with A plus X, if I divide X with A plus X, what do I get? This is now what I'll be calling as mole fractions of reactants and products at equilibrium. This is the mole fraction of A at equilibrium, mole fraction of B at equilibrium, mole fraction of C at equilibrium. And when mole fraction is multiplied by total pressure of the mixture at equilibrium, what do I get? I get a partial pressure. So, we have got A minus X divided by A plus X. If I multiply this term with total pressure of the mixture at equilibrium, now this term is what I call as the partial pressure of A at equilibrium. Similarly, if I multiply this term, X divided by A plus X, if I multiply this term with total pressure of the mixture at equilibrium, this is what I call as partial pressure of B. In the similar way, if I multiply this term with the total pressure of the mixture at equilibrium, what do I call this? I call this as the partial pressure of C at equilibrium. Am I clear with these terms? Am I clear with these terms, people? Quickly. And once you get the partial pressures of reactants and products, at equilibrium, you can put these values in this particular expression and get the value of Kp. So to calculate Kc, I need concentrations of reactants products at equilibrium. To calculate Kp, I need partial pressures of reactants products at equilibrium. Right? So here, let's try to do a few questions and make you understand all this stuff in detail. Have a look, guys. The first question which is on your screen. You are given with a reaction. The reaction is like this. A gas plus B gas is in equilibrium with 2 times C gas. Okay. The question says, initially at time t is equal to 0. We are starting with 2 moles of A, 1 mole of B, and already 1 mole of C is there in the container. The reaction is taking place in a vessel whose volume is 10 liters. The reaction is taking place in a container whose volume is 10 liters. Okay. What do I need to calculate? The question says the concentration of C at equilibrium is given. 0.2 molar. We are supposed to calculate Kc. Okay, First of all, tell me, how do we write the expression of Kc? I'll start with the product. It's going to be concentration of C at equilibrium raised by stoichiometric coefficient 2 divided by concentration of A at equilibrium raised by stoichiometric coefficient 1, concentration of B at equilibrium raised by stoichiometric coefficient 1. Okay. This is the expression of Kc. Now, in order to calculate the expression of Kc, in order to get the expression of Kc, what do I need? I need the concentrations of reactants and products at equilibrium. How exactly? Try to understand. I'm starting with 2 moles of A. Let's say at equilibrium, out of 2 moles of A, X have reacted. I'll be left with 2 minus X moles of A at equilibrium. Right? 1 mole of A reacts with 1 mole of B. So X moles of A would have reacted with X moles of B. So I'll be left with 1 minus X moles of B at equilibrium. Already there was 1 mole of C in the container. Now some extra moles of C would have got formed. 1 mole of A gives 2 moles of C. So X moles of A would have given 2 X moles of C. So these are the moles of A, B and C present in the container at equilibrium. Yes. These are the moles of A, B and C present in the container at equilibrium. Okay. Now, my dear students, if I divide these moles with the total volume is 10 liters. So what do I call these terms as? These are the concentrations of reactants products at equilibrium. Now, my dear students, if you look carefully, concentration of C at equilibrium is given. How much? 0.2. And this is the concentration of C at equilibrium. So technically, I would say 1 plus 2x divided by 10. This is equal to 0.2. 0.2 means 2 by 10. 10 cancel. X value comes out to be 0.5. If you got the value of x, put the value of x here. 2 minus 0.5 is 1.5. 1.5 divided by 10 is 0.15 molar. This is the actual concentration of A at equilibrium. Similarly, 1 minus 0.5 is 0.5 divided by 10. So 0.05 molar. This is the concentration of B in the container at equilibrium. And my dear students, this particular term, its value is already given to me. That's 2 by 10, which is 0.2 molar. Okay, so you got the concentrations of reactants products at equilibrium. And if you got the concentrations of reactants products at equilibrium, now get the value of Kc. Kc is equal to concentration of C at equilibrium, that is 0.2, raised power stoichiometric coefficient 2. Concentration of A at equilibrium, that is 0.15 raised power 1. Concentration of B at equilibrium, that is 0.05 raised power 1. Solve it, get the value of Kc, that's it. Okay. Solve it, get the value of Kc, that's it. Am I clear to everyone? Am I clear to everyone? Quickly. Quickly, people. I'm going to show you one more question. With that, things will get clear to you. Okay? I'm going to show you one more question. With that, things will get clear to you. Okay? I'm going to show you one more question. With that, things will get clear to you. That's why I told you this concept is, students find this particular concept tougher basically. Okay? To understand, what do? I calculate first of all the moles of reactants products at equilibrium, then divide them with the volume, I get concentration. And eventually I write the expression of Kc. See, for example, this is the question. You are given with a reaction. The reaction is simple. X plus Y in equilibrium with 2 times Z. This is the reaction. Okay? This is the reaction, my dear students. Now, as far as this particular question is concerned, if you look carefully, initially at time t is equal to 0, I'm starting with 1 mole of X. I'm starting with 1.5 moles of Y. And already in the container, 0.5 moles of Z were there before the start of the reaction itself. Before the start of the reaction itself, the moles of Z here in the container are 0.5. Now, people, tell me, how do we calculate the moles of reactants products at equilibrium? Say, assume that out of 1 mole of X, out of 1 mole of this reactant, assume that X moles have reacted. So I'll be left with 1 minus X moles of reactant. I'll be left with 1 minus X moles of this particular reactant at equilibrium. Now 1 mole reacts with 1. X will react with X. So I'll be left with 1.5 minus X. These are the moles of Y present in the container at equilibrium. Already there were 0.5 moles of Z in the container. Now some new moles of Z would have got formed. 1 gives 2, so X would give 2X. So these are the moles of reactants products present in the container at equilibrium. Right? Now, my dear students, divide these moles with the total volume. How much is total volume? That's 1 liter. So divide each of them with 1. What do I get? I'll be getting the concentration of each reactant product present in the container at equilibrium. So I got the concentrations. I got the concentrations of reactants products present in the container at equilibrium. Now, people, if you look carefully, in the question it's mentioning that. In the question they're mentioning that at equilibrium the concentration of Z is 1 molar. Concentration of Z at equilibrium is 1 molar. And we already know concentration of Z at equilibrium is this, right? Which is 0.5 plus 2x. This is equal to 1. That means 2x will be equal to 0.5. X would be equal to 0.25. So you got the value of X. If you got the value of X, put them here in this expression. 1 minus 0.25 comes out to be 0.75 molar. 1.5 minus 0.25 would be 1.25 molar. 0.5 plus 2x. 0.5 plus 2x is equal to 1. So this 1 molar. So you got the concentrations of reactants products at equilibrium. And people, if you got the concentrations of reactants products at equilibrium, you can write the expression of Kc. Right? That's what you have to calculate. Kc. Kc is simply going to be concentration of Z at equilibrium raised power 2 divided by concentration of X at equilibrium raised power 1, concentration of Y at equilibrium raised power 1. Now concentration of Z at equilibrium is equal to 1 the square divided by concentration of X at equilibrium is nothing but 0.75 raised power 1. Concentration of Y at equilibrium is again 1.25. So solve this particular term and get the value of Kc which you were supposed to calculate. Am I clear to everyone? Say yes or no in the chats quick. Say yes or no in the chats quick, people. Everybody. 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 Yeah? Perfect. I believe this sort of a question you can easily solve from now on. Now they have asked you, they have told you the value of this particular term is equal to X divided by 15. Now you can cross multiple and get the value of X, and the value of X will come out to be 16. Okay? The value of X would come out to be 16. I hope I'm clear with this. Now one more question, slightly different one. Slightly different one. If you look at this particular question, we have to calculate the Kp for the the reaction is decomposition of HI. So the reaction has to be 2 times HI gas, right? It gives H2 gas plus I2 gas. This is your reaction. Now, as far as the question is concerned, initially at time t is equal to 0, we are starting with 1 mole of HI. So this would be 0 in the beginning, this would be 0 in the beginning, right? The volume of the vessel here is equal to 2 liters. As per the question, Kp value is given to me as 16. Okay. Now guys, one thing. Can you calculate delta Ng for this reaction? Have you heard about delta Ng? Delta Ng is equal to number of moles of gaseous products, which is 1 plus 1, 2, minus number of moles of gaseous reactants, which is 2. So 2 minus 2 is 0. So delta Ng for the reaction is 0. Number of moles of gaseous products minus number of moles of gaseous reactants. So delta Ng is 0. If delta Ng is 0, you should have heard about this expression Kp is equal to Kc RT raised power delta N, right? Delta N is 0. Anything raised power 0 is 1. So Kp Kc would be equal for the reaction. That particular reaction was delta Ng is 0. Its Kp and Kc are equal. So if it is Kp, automatically it means that it is the value of Kc as well. Right? Automatically it means that it is the value of Kc as well. Now, my dear students, we are almost done. So at equilibrium, from 1 mole of reactant, let's say X moles got converted into product. So I'll be left with 1 minus X moles of reactant. Now, 2 moles gives us 1 mole. So 1 mole gives us 1 by 2 moles. X gives us X by 2 moles. Even this is going to be X by 2 moles. So what did I get? I got the moles of reactants products at equilibrium. I got the moles of reactants products present in the container at equilibrium. Now what I'll be doing? I'll be dividing these moles with the total volume. What is the total volume of the container? 2 liters. So divided by 2. This is divided by 2. This is divided by 2. So I got the concentration. Concentration of this reactant at equilibrium is 1 minus X by 2. This becomes X by 4. Even this becomes X by 4. So I got the concentration of reactant and product present in the container at equilibrium. I got the concentration of reactant and product present in the container at equilibrium. Okay. Now, my dear students, try to understand. What do I need to calculate as per the question? As per the question, they're asking me to calculate the concentration of reactant product at equilibrium. I need to get this value. So basically, I technically need to get the value of X. Now, how do I get the value of X? For that, Kc value as per the question, we know is 16. If I write the Kc expression will be concentration of X2 at equilibrium, which is X by 4, multiplied by concentration of I2 at equilibrium, which is again X by 4, divided by concentration of Hi at equilibrium, which is 1 minus X divided by 2, raised power stoichiometric coefficient, that's 2, and this value is equal to 16, right? Now, this is going to be X square by 4 ka square, whole divided by 1 minus X divided by 2 ka square is equal to 16. Perfect. Now, a bit of calculation is needed. Correct? A bit of calculation is needed. Now, how would you calculate this particular term? How would you calculate this particular term? For that, I need some space. I should have written all this here. Anyways, let's try to solve this. First of all, this is 2 ka square is 4. So 1 4, right? This 4 and one of the 4 gets cancelled out. So I'll be left with x square divided by 4 whole divided by 1 minus x ka square. This value is equal to 16. Perfect. Or I'll be writing x square divided by 2 multiplied by, or let me write it like this in simple terms. X divided by 2 into 1 minus x ka whole square is equal to 16. So take square on that side, it becomes root. So x divided by 2 minus 2x is equal to 4, which means that x is equal to 8 minus 8x. So that means 9x is equal to 8, which tells you that x is equal to 8 by 9. This is a bit lengthy question, by the way. So if x is equal to 8 by 9, put the value of x there, you'll be getting the concentration of H at equilibrium. Put the value of x here, get the concentration of H2 at equilibrium. Put the value of x here, get the concentration of I2 at equilibrium. Right? Am I clear to everyone? Let me know once in the chats. And people, these sort of questions are asked. These sort of questions are asked in your exam. Remember that. Okay? Remember that. Remember that. My dear students, one more concept. That is your Raoult's law from the chapter solution. Okay? Raoult's law from the chapter solution. Have you studied this topic before? Raoult's law? Have you studied this particular topic before? The Raoult's law. Concept number 5. This is again one of the concepts from which questions will be asked. Okay? Again one of the concepts from which questions will be asked. So try to understand very carefully what I'll be doing. For example, this is my container. Let's say this is one more container. Okay? Let's say this is one more container here. Imagine that in this particular container, we have got a volatile liquid A in this container. Okay, volatile liquid A in the container. In the second container, imagine that we have got a volatile liquid B. We have got a volatile liquid B in the second container. Okay. My dear students, if liquid A is volatile, that means you will find vapors of A here. These are the vapors of A, right? Let the vapor pressure of A in pure state is equal to P naught A. So what is P naught A? It is nothing but vapor pressure of A. Vapor pressure of A. In which state? In pure state. Vapor pressure of A in pure state. Correct? My dear students, this is the volatile liquid B. So here you will find the vapors of B as well. So here I am mentioning a term P naught B, which represents vapor pressure of B in pure state. Vapor pressure of B in pure state. Okay. Now, my dear students, you are adding these two liquids in this particular container. So in this particular container, what would you get? You'll be getting a solution of A and B. You'll be getting a solution of A and B. Here, A is the volatile component as well as B is the volatile component. So over here, you will find vapors of A as well as B. You'll find vapors of A as well as B. You'll get vapors of A as well as B here. Let the vapor pressure of this solution be PS. PS represents the vapor pressure of the solution, right? Let PS be the vapor pressure of the solution. And I would say vapor pressure of the solution. The vapor pressure of solution, is it only going to be due to the vapors of A or vapors of B, or both would have contributed? I would say vapor pressure of the solution would be due to the vapors of A as well as vapors of B, right? What is this PA here? This is what you call as partial vapor pressure of A. This is what you call as the partial vapor pressure of A. Right? This is what you call as partial vapor pressure of B. This is what you call as partial vapor pressure of B. What does that mean? I would say this PA, it is the contribution made by the vapors of A. It is the contribution made by the vapors of A towards the total vapor pressure of the solution. This is the contribution made by the vapors of B towards the total vapor pressure of the solution. Okay? And as per your Raoult's law is concerned, this partial vapor pressure of A is nothing but it is equal to P naught A multiplied by chi A. And similarly, remember, your partial vapor pressure of B here is nothing but P naught B multiplied by chi B. P naught B multiplied by chi B. Now, remember what is this chi A and chi B? You need to know them as well. If I talk about chi A is the mole fraction of A. Mole fraction of A in the solution phase. In solution phase. Or I can say mole fraction of A in the liquid phase. Mole fraction of A in the liquid phase. Similarly, chi B. Chi B is also the mole fraction of B in the liquid phase. Okay? If I talk about chi B is again, I would say, the mole fraction of B in liquid phase. In liquid phase. So, my dear students, since we know total vapor pressure of the solution is nothing but PA plus PB, right? Now, I can say PS is nothing. Instead of PA, I can write P naught A chi A. Instead of PB, I can write P naught B chi B. This is one of the equation which you guys will be remembering. This is one of the equation which you guys will be remembering. Okay? This is one of the equation which you guys will be remembering. Total vapor pressure of the solution is equal to P naught A chi A plus P naught B chi B. Number one. Number one. Number one. I'm clear? Number two, people. Number two. Here you will find in this particular chamber, in this particular part of the container, you will find vapors of A as well as B. You will find vapors of A as well as B. Now, if I ask you what is the mole fraction of A in the vapor phase, there is a question asked. What about the mole fraction of A in the vapor phase? What about the mole fraction of B in the vapor phase? Chi dash A, chi dash B. Directly remember the results. This is equal to P naught A chi A divided by PS. This is equal to P naught B chi B divided by PS. These are the two results which I'm not deriving right now. I'm just giving you the results. Remember them. But the terminologies which I've specified here, do remember their meaning. Chi A here is nothing but it is the mole fraction of A in liquid phase. Chi B is mole fraction of B in liquid phase. Chi dash A is the mole fraction of A in the vapor phase. Chi dash B is the mole fraction of B in the vapor phase. Okay? Remember these two results as well, they're asked. Perfect. Let's try to solve only one question from which all the concepts will be clear. From which all the concepts will be clear. Okay? Right? Perfect. Perfect, guys. Who is this devil? Devil is telling me something. Sir, you are teaching the same things as you used to teach 2 years before. Because 2 years before also I was teaching NEET, now also I'm teaching NEET. Okay? 2 years before I was not compromising on the content, now also I do not compromise on the content. Okay? So, whosoever has paid you to write all this stuff here, you can go there. Okay? Chalo, let's move on. My dear students, give this question a try. Give this question a try, quickly. Give this question a try quickly. Our notes you guys are going to get in the Telegram. Telegram channel name is Wassim Bhat Chemistry Official. Okay? Wassim Bhat Chemistry Official is the Telegram channel name. What is the answer of this question? Quickly, it's a simple question, guys. Also, in the same question, let me add certain things. Let me add one more question. Also calculate mole fraction of A in the vapor phase and mole fraction of B in the vapor phase. Add these two questions as well. Quickly. Give this question a try. Everyone, guys, everyone. See, as far as this particular question is concerned, if you look carefully, the vapor pressure of two pure liquids P and Q, let's call them as A and B. So basically, P naught A value is given to me as 80 torr and P naught B value is given to me as 60 torr. Okay. Now, the total vapor pressure of the solution obtained by mixing 3 moles of P and 2 moles of Q. So, we are mixing 3 moles of A. We are mixing 3 moles of A and how many moles of B? 2 moles of B. 3 moles of A and 2 moles of B. Right? Now, my dear students, the first thing, calculate the total vapor pressure of the solution, which is nothing, P naught A chi A plus P naught B chi B. Okay, what is P naught A? P naught A is 80. Now, mole fraction of A. Mole fraction of A means moles of A divided by total moles is 3 plus 2, 5. Plus P naught B. P naught B is 60. Mole fraction of B. Moles of B divided by total moles. Perfect. How much this value comes out to be? Can you let me know in the chats? Can you let me know in the chats? People are saying 72. So I'm believing you. Let 72 torr be the total vapor pressure of the solution. So this is done. What is the second thing? What is the second thing, people? What is the second thing? We are supposed to calculate vapor pressure of, mole fraction of A in the vapor phase. Mole fraction of A in the vapor phase would be equal to P naught A chi A divided by PS. P naught A, that is 80. Chi A, how much is chi A? Chi A would be 3 by 5. PS, what is PS? PS is 72 torr. Solve this, get it done. Mole fraction of B in the vapor phase. P naught B, chi B divided by PS. You can get the mole fraction of B in the vapor phase as well. Am I clear, people? Am I clear? Am I clear? Am I clear to everyone? Quickly. If a question is asked from this, see, in the question, either you'll be asked to calculate the total vapor pressure of the solution, or simply you'll be asked to calculate the mole fraction of A and B in the vapor phase. So I believe you can easily solve it now. Okay? All right. Can you give this question a try? Simple, basic question. Simple and basic question this is. Simple and basic question this is. We have to find, we have to match the options. See guys, I told you PS is equal to P naught A chi A plus P naught B chi B. This is one of the equations which I gave you. Let's do one thing. Let's do one thing. P naught A chi A I'm writing as such. P naught B instead of chi B, if I write 1 minus chi A, does not make a difference. Okay. So this is going to be P naught A chi A plus P naught B minus P naught B chi A. Correct? So here, this and this, chi A is common. So I'll write first of all P naught B plus, among these two terms, I'll take chi A out. So it becomes P naught A minus P naught B multiplied by chi A. So this is the total vapor pressure of the solution which I was supposed to calculate. So which option is satisfying it? Which option is satisfying it, people? It's option D. Right? It's option D. It is PB plus chi A multiplied by P naught A minus P naught B. This is basically P naught everywhere. I believe this sort of equation, if asked, okay, I believe this sort of equation, if asked, you can easily solve it. Am I clear to every one of you? Am I clear to every one of you people? Okay, so how many concepts done till now? How many concepts done till now? Everyone. How many concepts done till now? All right. So I'm moving on to one more concept which is also frequently asked. What is that? That's experimental determination of order. See, this is also one important concept from which questions are frequently asked. And this particular concept I'll be teaching you directly in the form of questions so that you'll understand it properly. See guys, this is the sort of question which is asked. This is a sort of the question which is asked. Okay. If you remember last year in your NEET examination, the question of the similar type was asked. The question of the similar type was asked. Now here, in this particular question, we are given with a balanced chemical equation. There are some experimental values which are given to us, and we are supposed to calculate order of this particular reaction. We are supposed to calculate order of this particular reaction. My dear students, remember one thing. In order to calculate the order of the reaction, we are supposed to write the rate law first. We are supposed to write the rate law. Okay. If I write rate law for this reaction, rate law is like this. R means rate of reaction, is equal to K, that is rate constant, multiplied by concentration of reactant raised power X, concentration of one more reactant raised power Y. Right? This is how you write the rate law. I hope you know that. This is how you write the rate law. And people, this X is what you call as order with respect to NO. Y is called as order with respect to H2. X plus Y will give you the overall order of the reaction. And this overall order of the reaction is to be calculated. This overall order of the reaction is to be calculated. Now, how do we get the overall order of the reaction? Try to understand very carefully what I'll be doing. See, my dear students, in this rate law, I am going to fit the details of experiment number 1. As per experiment number 1, rate of the reaction is equal to 3 into 10 raised power minus 5. So R is equal to 3 into 10 raised power minus 5 is equal to K. Concentration of NO here. Concentration of NO here is 5 into 10 raised power minus 3 whole raised power what? X. Concentration of H2 here is 2.5 into 10 raised power minus 3 raised power Y. This is my equation number 1. This is my equation number 1. Similarly, put the experiment number 2 data in the same equation. In the experiment number 2, what is rate? Rate is 9 into 10 raised power minus 5. 9 into 10 raised power minus 5 is equal to K. Is equal to K. Concentration of NO in the second experiment, that is 15 into 10 raised power minus 3 raised power X. Concentration of H2 in the second experiment, that is 2.5 into 10 raised power minus 3 whole raised power Y. Fit the experiment number 3 data here in this equation. Rate of the reaction here is 36 into 10 raised power minus 5. 36 into 10 raised power minus 5 is equal to K. Concentration of NO in the third experiment is 15 into 10 raised power minus 3 raised power X. H2 concentration in the third experiment is 10 into 10 raised power minus 3 raised power Y. So how many equations did I get? I got 3 equations, right? I got 3 equations. Let's do one thing. Calling this equation 1, calling this equation 2, calling this equation 3. Let's divide equation 2 with equation 1. My dear students, if I divide equation 2 with equation 1, 10 power minus 5, 10 power minus 5 cancel. 9 divided by 3 comes out to be 3 is equal. K and K cancels. This term cancels. 10 power minus 3, 10 power minus 3 cancel. 15 divided by 5 is 3, but this is 3 raised per x. 3 raised per 1 is equal to 3 raised per x, which means that x value is nothing but 1. X value is nothing but 1. Okay. X value is nothing but 1. Similarly, if I divide equation 3 with equation 2, this divided by this, 36 divided by 9 is 4, is equal. This whole term cancels out. This term cancels out. 10 divided by 2.5 is 4, so it is 4 raised per y. Now, 4 raised per 1 is equal to 4 raised per y, which means that y value is equal to what? Is also equal to 1. Right? Did we do any mistake here? 36 divided by 9 is 4, 4 raised per 1 is, no, it's correct. X value is 1, y value is 1, so overall order of the reaction would be equal to 1 plus 1, that comes out to be 2. Am I clear with this? Am I clear with this particular question, people? Am I clear with this particular question? So first of all, whenever you see this sort of equation, what you are supposed to do is, you are supposed to make 3 equations. Divide these 3 equations. Do some calculation, right? Get the value of x, get the value of y, add them up, and you'll be getting the overall order of the reaction. This sort of equation is asked in your exam. Okay? Can you solve this question on your own right now? Similar sort of question, right? I want you guys to give it a try. I want you guys to give it a try. Everyone. Can you? Can you people? Similar type of question. Slightly the values are different. Slightly the values are different. If you look at the question carefully, what is the first thing you are supposed to do? You are supposed to write the rate law. How do I write the rate law? R is equal to K. Concentration of NO raised per X. Concentration of Cl2 raised per Y. Put the experiment number 1 data in this equation. As per experiment number 1, rate is equal to 1 into 10 raised per minus 3 is equal to K. Concentration of NO in the first experiment is 0.05. Concentration of Cl2 in the first experiment is again 0.05. Calling this equation number 1. Calling this equation number 1. Now, put the experiment number 2 data here in the same equation. R in the second experiment is 3 into 10 raised per minus 3. 3 into 10 raised per minus 3 is equal to K. Concentration of NO in the second experiment is 0.05 raised per X. Concentration of Cl2 is 0.15 raised per Y. So equation number 2. Similarly, put the experiment number 3 data in the same equation. So in the experiment number 3, R is equal to 9 into 10 raised per minus 3 is equal to K. Concentration of NO. Concentration of NO is 0.15 raised per X. Concentration of Cl2 is 0.05 raised per Y. Calling this is equation number 3. How many equations I got? 3 equations. Right? So what am I supposed to do now? Divide equation 2 with equation 1. When you divide 2 with 1, what do I get? 10 power minus 3, 10 power minus 3 cancel. 3 by 1 is 3 is equal. This term cancels out. 0.15 divided by 0.05. That's 3. So this becomes 3 raised per Y. This is telling you that Y value has to be 1. Got the value of Y? Got the value of Y? Right? Now similarly, for example, let's divide equation 3 with equation 1. Let's divide equation 3 with equation 1. 10 power minus 3, 10 power minus 3 cancel. 9 divided by 1 is 9 is equal. This term cancels out. 0.15 divided by 0.05. That is 3 raised per X. 3 raised per X is equal to 9. That means X value has to be equal to 2. So you got X, you got Y. So I can say the overall order of the reaction has to be X plus Y, that is 3. Overall order of the reaction has to be X plus Y, that is 3. Am I clear to everyone quick? Am I clear to everyone quickly in the chats? Everyone, people. "30 minutes. Is it clear? Everyone, is it clear? I hope this sort of a question, if it comes in your exam, you should be in a position to solve this. Okay? Now, my dear students, one more concept, which is frequently asked. Questions related to zero order reactions. Questions related to zero order reactions. My dear students, first of all, let's say I've got the reaction A gives B. I'm assuming that order of this particular reaction is zero. Assuming that order of this reaction is zero. So this is first of all a zero order reaction. This is first of all a zero order reaction. Now, my dear students, let's say at time t is equal to 0, the initial concentration of reactant is A0. This is 0. At time t, the concentration of reactant left is 80. The concentration of reactant left is 80. And the concentration of product formed, that is BT. First of all, remember these terminologies. What is A0? A0 is nothing but it is the concentration of reactant. Concentration of reactant at time t is equal to 0. AT is nothing but it is the concentration of reactant left at time t. Left at time t. Yeah? Okay. Right, people? Sir, x is equal to 1 and y is equal to 2 hoga. Check. Maybe I have done some mistake. Let's check. Let's check. In experiment number 1, rate is 3 in 10 power minus 5 K. NO concentration 5 in 10 power minus 3. This is 2.5 into 10. This is correct equation. Second equation, 9 in 10 power minus 5 is equal to K. NO concentration is 15. This is 2.5 raised power this. Okay. Third, it is rate of the reaction 36 into 10 raised power minus 5 K. Concentration of NO is 15. This is 10. Okay. So equation 2 divided by equation 1. This becomes 3. Right. This term cancel out. This is 15 divided by 5 is 3. 3 raised power x. So x is 1. Correct. Divide equation 3 with equation 2. 36 divided by 9 is 4. Right. This term cancels out. 10 divided by 2.5 is 4. So 4 raised power. 10 divided by 2.4 raised power y. 4 raised power. This is correct only. This is not wrong. You are doing something wrong. I've done correctly. Okay, let's move on. Let's move on, guys. So basically, A0 is the concentration of reactant at time t is equal to 0. Similarly, AT is the concentration of reactant left at time t. Okay. Now, my dear students, understand. Now, my dear students, understand. The first equation which I'm not deriving here, I'm just giving you the equation which I'll be frequently using in the questions. That is your integrated rate equation. That is nothing but AT is equal to A0 minus KT. AT is equal to A0 minus KT. Remember, this equation is only valid for zero order reactions. And this equation is what you call as integrated rate equation for the zero order reactions. This is what I call as integrated rate equation for the zero order reactions. Okay. Someone is saying, sir, another question. Okay, what is the another question? What is the another question? This is the another question, right? I divide equation 3 with equation 2 with 1. So this is 3. This term cancels out. This is 3 raised power y. That's 1, correct? Equation 3 divided by equation. This term cancel. So this is 9. This term cancels out. So this also 3 raised power x. So this also right. What are you saying? 2 plus 1 is 3. Where is the mistake? Where do you find the mistake here? It's correct only. Yeah? See, 0.5, 0.5, 0.15. Cl2 is 0.05. This is 0.15. This. I think you are doing the mistake here. Over here, the first quantity is Cl2. Cl2 concentration is given first. Then NO concentration is given. Here, you are writing NO first, then Cl2. I think that is the mistake which you guys are doing. I think that is the mistake which you guys are doing. Okay, look at the question carefully. Look at the question carefully. Try to solve it. Okay, I'm moving on, guys. So first of all, this is your integrated rate equation. This is your integrated rate equation for the zero order reactions. Integrated rate equation for the zero order reactions. Point number 1. Point number 2, my dear students, that is, this was point number 1. Point number 2, how do we calculate half-life in case of zero order reactions? Half-life or you can call it as T50%. What is half-life or T50%? Half-life or T50% is nothing. It is just the time taken to complete 50% of the reaction. Okay? Time taken to complete, I'm writing it. Time taken, you know it already. Time taken to complete 50% of the reaction. And in case of your zero order reactions, remember T half is nothing but it is equal to A naught divided by 2K. Again, I'm not deriving this expression, just remember it directly. Okay? Just remember it directly. Concept number 3. How do we calculate T 100%? Time taken to complete 100% of the zero order reaction. Remember, it's nothing but it's equal to A naught divided by K. It's equal to A naught divided by K. This can be the third thing which can be asked in the questions, right? Similarly, will there be any relation between T 100% and T 50%? See, if you divide T 100% with T 50%, T 100% is equal to A naught by K, T 50% is equal to A naught divided by 2K. So I can say T 100% is equal to 2 times the T half. 2 times the T half. What does it mean exactly? It means that a zero order reaction is completed. It means that a zero order reaction is completed in how many half-lives? In 2 half-lives. Remember this particular equation as well. This is also asked. Okay. Similarly, there can be one more parameter asked, degree of dissociation alpha, which is equal to KT divided by A naught. I'm directly giving the expressions. I'm not deriving any. Alpha, degree of dissociation for zero order reactions, KT divided by A naught. Okay. KT divided by A naught. Perfect. Right, people? So now you can, I believe, easily solve the questions. In majority of the questions, what you have to do, you have to use this equation and you have to use this equation. And how you'll be using the equation, let me show that to you. How you'll be using the equation, let me show that to you. Tell me first of all the answer of this question. Quick. What is the answer of this question? Everybody. Everybody in the chats. When initial concentration of reactant is doubled, what happens to half-life? When initial concentration of reactant is doubled, what happens to half-life? Simple. Half-life of the zero order reaction is nothing but A naught divided by 2K. Now, if you double the initial concentration, half-life automatically doubles, right? Half-life also doubles, correct? Both are directly proportional. If you double this, this becomes double. If you triple this, this becomes triple, right? If you make it 4 times, this becomes 4 times. But this is valid only for the zero order reactions. This is valid only for the zero order reactions. Okay, one thing which I forgot to tell you. Sometimes they'll ask you a question. Calculate the concentration of B at time t. The concentration of A at time t, you'll calculate from this equation. Concentration of A at time t, you'll calculate from this equation. Concentration of B at time t would be equal, for this equation, it would be equal to simply KT. Okay? Remember this as well. Concentration of B at time t is nothing but KT. And there was a question which was long back asked from the same thing. This was the question. This was the question. The rate constant of the reaction A gives B is equal to 0.6 into 10 raised power minus 3 moles, liter inverse, second inverse. Right? If the concentration of A is 5 molar, then the concentration of B after 20 minutes. After 20 minutes, I have to check what is the concentration of B. After 20 minutes, I have to check what is the concentration of B. I told you a few minutes back. Concentration of B at time t is nothing but K multiplied by T. What is K? K is given to me as 0.6 into 10 raised power minus 3. T is 20, but minutes, so make it in seconds multiplied with 60. You'll solve it. The answer comes out to be 0.72 molar. 0.72 molar. Okay? This is again one of the sort of the questions which can be asked. All right? Okay, one basic question which I believe you all can easily solve. This is your one of the questions asked in NEET 2020. Half-life of the zero order reaction. Half-life of the zero order reaction is given to me as 100 seconds. Having 0.02 molar initial concentration. Initial concentration of reactant is how much? 0.02 molar. Rate constant of the reaction is, let the reaction is A gives B. It's a zero order reaction. I need to calculate its rate constant. Can't you solve it, guys? Can't you solve it? A very basic equation this is. A very, very, very basic question this is, I must say. See guys, I told you a few minutes back, T half for the zero order reaction is nothing but A naught divided by 2K, or you can say K is nothing but A naught divided by 2 into T half. What is A naught? A naught is 0.02. 2 multiplied by T half is 100. Solve and kill it. All clear? All clear, people? All clear, all clear, all clear? You should be in a position to solve this as well. That's great. That's great. Now comes your first order reactions. Okay. Like I gave you certain expressions in the zero order reactions, in the similar way, you guys are going to remember some of the expressions in the first order reactions as well. See, this is my reaction A gives B. This is more important. A gives B, whose rate constant is K. Order of the reaction is 1. Okay. The reaction follows the first order kinetics. Initially at time t is equal to 0, its initial concentration is A naught, this is 0. Now at time t, the concentration of reactant left is AT, the concentration of product forms is BT. Okay. Now here we have got certain expressions. Every single expression is important. I'm not deriving any, I'm just giving you the expressions. Okay. The first expression, that is ln of AT is equal to ln of A naught minus KT. This is the first form of the integrated rate equation for the first order reactions. Second, log of AT is equal to log of A naught minus K divided by 2.303 multiplied by T. This is the second expression. This is the second form of integrated rate equation for the first order reactions. Okay. The third one. Third one. K is equal to 1 divided by T ln of A naught divided by AT. The third expression for the integrated rate equation for the first order reactions. Fourth, K is equal to 2.303 divided by T log of A naught divided by AT. This is the fourth expression for the integrated rate equation for the first order kinetics, right? Similarly, remember AT is equal to A naught e raised power minus KT. This is one more expression for the integrated rate equation for the first order reactions. If I talk about the half-life, T half for the first order reactions is nothing but 0.693 divided by K. Completion time here is equal to infinite. That means first order reaction never undergoes 100% completion. Remember this particular point as well. A first order reaction never undergoes 100% completion. A first order reaction takes infinite time for the completion. One more expression, important expression. Similarly, time taken to complete X% of the first order reaction. Time taken to complete X% of the first order reaction is nothing but 2.303 divided by K. It is a log of 100 divided by 100 minus X. Time taken to complete X% of the first order reaction. Time taken to complete 75% of the first order reaction is equal to 2 times the half-life. Time taken to complete 87.5% of the first order reaction is equal to 3 times half-life. Time taken to complete 99.9% of the first order reaction is equal to 10 times half-life. These are some direct results, some direct shortcuts, which you can remember. Anything can be asked out of this. Anything can be asked out of this, people. Okay, anything can be asked. Perfect. 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 Okay, one more expression which you study in your physics as well. Concentration of reactant left at time t is equal to A naught divided by 2 raised power n, where n represents the number of half-lives, which is total time divided by T half. Concentration of reactant left after n half-lives is equal to A naught divided by 2 raised power n. Similarly, your degree of dissociation for zero order reaction was, what was that? That was KT divided by A naught. Here it's going to be 1 minus e raised power minus KT. For this particular reaction A gives B, the degree of dissociation for the first order kinetics is equal 1 minus e raised power minus KT. All these expressions are important. Anything can be asked out of all this, right? Anything can be asked out of all this. For example, for example, for example, the first and the basic question, which all of you can kill, your NEET 2022 question. Your NEET 2022 question. Yes, even JE aspirants can also watch it. It'll ease out your preparation. See guys, you have got the reaction A gives B. Okay. Initial concentration of A. Initial concentration of A is 0.1 molar, which becomes 0.01 molar, which becomes 0.01 molar after 5 minutes. Which becomes 0.01 molar after 5 minutes. And the concentration of reactant left we represent with 80. We have to calculate rate constant. We have to calculate rate constant in minute inverse. In minute inverse. That means rate constant is minute inverse. It means it is of the first order. It follows the first order kinetics. Now I'll be using the simple integrate rate equation. K is equal to 2.303 divided by T log of A naught divided by 80. Okay. Now, this is the condition which you guys are going to put in this particular expression. So I would say K is equal to 2.303 divided by T log of A naught. A naught is 0.1 divided by AT. AT is 0.01. Sorry, it is 0.001. 0.001. So it's 10 raised power minus 3. So I would say it is 2.303 divided by 5 log of, this is going to be 10 raised power 2, which comes out to be 2 log 10. So 2 comes to the front. So 4.606 divided by 5, right? Minutes, which comes out to be 0.9 something. So 0.9 minutes is going to be 0.9 minute inverse is going to be the rate constant of the reaction, right? A simple basic question, this again, right? Okay. All right, guys. So simple. I mean, this is the condition is given in the question. Put this condition in the rate, in the expression, integrate rate expression, solve it and get the rate constant. There is no need to think. Even in the same question, they would have asked about the half-life. If they asked about the half-life, you got the rate constant. Half-life, you know, 0.693 divided by K. K you got, half-life you can calculate easily. Easily. Okay. An organic compound undergoes a first order decomposition. Time taken for its decomposition to 1/8 and 1/10 of its initial concentrations are T1 by 8 and T1 by 10 respectively. Calculate T1 by 8 divided by T1 by 10 multiplied by 10. Okay. Again, a simple question. This is not that difficult. See, imagine the reaction is of this type. A gives B. Now, for example, at time T is equal to 0, the initial concentration of reactant is A naught. This is 0. As per the question, at time T is equal to T1 by 8, the concentration of reactant left is A naught by 8. And the concentration of reactant left is represented by 80. Okay. Second condition says, at time T is equal to T1/10, concentration of reactant left is A naught by 10. And the concentration of reactant left is represented by 80. Okay, so how many conditions I have? I have 2 conditions. Over here, if you look carefully, I have 2 conditions. What is my integrate rate equation? That is K is equal to 2.303 divided by T. It is the log of A naught divided by 80. Now put first condition in this expression. I'll be getting K is equal to, or let's do one thing. Let me take T out here, K out here. Let me write T here and K here. Now, if I put this condition here, instead of T, I'll be writing T1/8 is equal to 2.303 divided by K. This is the log of A naught divided by, what is 80? 80 is A naught by 8. So A naught cancels out. 8 comes up. 8 comes up. 8 means 2 raised power 3. Log of 2 raised power 3 means 3 log 2. Log of 2 raised power 3 means 3 log 2. 3 log 2 is how much? 0.3. So 3 into 0.3 is nothing but 0.9. It is 0.9. So this is T half. I mean, this is T1/8. Similarly, what about T1/10? I mean, put this over here. So T1/10 is equal to 2.303 divided by K log of A naught divided by, what is 80 here? 80 is A naught by 10. So A naught did not cancel. Log 10 comes out to be 1. Okay. What I need to do? I need to divide these 2 equations. T1/8 divided by T110. Comes out to be how much? This term cancels. It comes out to be 0.9. But in the question, I have to get the value of this term. T1 divided by 8, whole by T1 by 10 multiplied by 10. So I have to multiply this term with 10 as well. 10 multiply on this side, multiply on this side. The overall value comes out to be 9. So 9 is going to be the correct answer of this particular question. Simple. I wrote the integrated equation. Put the first condition here, put the second condition here. Divide the two, multiply by 100. You'll be getting the exact value here as 9. Right? Perfectly done, people. This sort of a question you should be in a position to solve. Okay, fast. See what was the question asked in your NEET 2020, a basic question. And you can expect these sort of questions, guys. This is the level of your NEET examination. The rate constant of the first order reaction. You have got the first order reaction A gives B, whose rate constant K is equal to 4.6 into 10 raised power minus 3 second inverse. The time required to reduce 2 grams of reactant, the time required to reduce 2 grams of reactant to 0.2 grams. So this is the initial amount. This is the amount of reactant left after some time. This is the amount of reactant left after some time. What is my integrated equation again? So K is equal to, or I'll say T is equal to 2.303 divided by K. This is the log of A0 divided by AT. Now do one thing. Put this condition here in this expression. So you'll write T is equal to 2.303 divided by, what is K? K is 4.6 into 10 raised power minus 3 log of, what is A0? A0 is 2. What is AT? 0.2. Perfect. So this term becomes 10. Log 10 is 1. So T here you can easily calculate. T here you can easily calculate. 10 raised power 3 goes up. This is 1. This is 2. So 10 raised power 3 divided by 2, which comes out to be approximately 500 seconds. So the time required to reduce the amount of reactant from 2 grams to 0.2 grams is nothing but that's 500 seconds. Option B has to be the correct answer. I hope you're getting what I'm trying to say. Okay? I hope all this is clear. I hope all this is clear. Again, if you look at this question, again, it has been asked in your NEET 2019. And similar sort of question, you can easily solve it. You are supposed to calculate time required for the completion of 99% of the reaction. So time taken to complete X% of the reaction. Time taken to complete X% of the reaction. I gave you the result few minutes back. Time taken to complete X% of the reaction is nothing but 2.303 divided by K. This is a log of 100 divided by 100 minus 6. Now they are asking time taken for 99% completion. So X is equal to 99. Put the value of X here in this expression. So I'll be writing T 99% is equal to 2.303 divided by K. This would be log of 100 divided by 100 minus 99 is 1. Now it becomes log of 10 square. Log of 10 square means 2 log 10. 2 log 10. So 2 here, log 10 is 1. So it's going to be simply 4.606 divided by K. Right? A simple basic question and you can kill it. So option C is the correct answer of this particular question. Right? And I believe you would have solved this question many a times as well. Yeah? A simple and basic one this is. A simple and basic one this is. See, even this is the similar sort of question. Even this is a similar sort of question. You can give it a try on your own. So this can be your homework question. Now, my dear students, how many concepts are we done till now? How many concepts are we done with till now? Quickly. Let me know in the chats. How many concepts are we done with? Six or seven? I think 7. 8. Chalo, I have no count, right? This is going to be the next concept now. Next concept. What is it? This is the kinetics of a first order. Kinetics of a first order gaseous phase reaction. Kinetics of a first order gaseous phase reaction. Okay. See guys, why this is important? See why this is important. For example, I have got a homogeneous gaseous phase reaction like this. A gas gives B gas plus C gas. Okay. If I write time t is equal to 0, I'm assuming first of all, the reaction follows the first order kinetics. It's a first order reaction. Initially at time t is equal to 0, if I ask you how many gases will be there in the container. Initially at time t is equal to 0, there will be only one gas in the container. That will be gas A, right? So whatever is the pressure of the container, initially, that's due to A, which is P naught, right? So this would be initially 0, this would be 0. At time t is equal to 0, when the reaction has not started, when B has not got formed yet, when C has not got formed yet, at that point of time, there is only A in the container. So there is only one gas in the container at time t is equal to 0. So all the pressure at time t is equal to 0 will be due to A, which is P naught, which is P naught. Let's say at time t, since when the reaction starts, moles of A in the container will decrease. So pressure due to A in the container will decrease. Let's say at time t, pressure due to A is P naught minus X. Pressure due to A is, for example, P naught minus X. Pressure due to A has decreased. It was initially P naught, now P naught minus X. Now, 1 gives 1, so X gives X. 1 gives 1, so X gives X. Now I'm asking you a question. At time t, how many gases will be there in the container? At time t, there will be 3 gases in the container. There will be gas A, there will be gas B, there will be gas C. So at time t, I would say there will be a gaseous mixture in the container. At time t, there will be a gaseous mixture in the container. And I would say total pressure of the mixture at time t, total pressure of the gaseous mixture at time t would be equal to P naught minus X plus X plus X. P naught minus X plus X plus X. So X and X got cancelled out. So I would say X is nothing but P naught minus PT. X is nothing but P naught minus PT. Okay. X is nothing but P naught minus PT. Now a question is asked. Get the rate constant of the reaction in terms of. Get the rate constant of the reaction in terms of P naught and PT. Get the rate constant of the reaction in terms of P naught and PT. See guys how simple it is. You know K is equal to 2.303 divided by T log of. It used to be A naught divided by AT. It used to be A naught divided by AT. What was A naught? A naught was the concentration of reactant at time t is equal to 0. A naught was the concentration of reactant at time t is equal to 0. But here, instead of concentration of reactant at time t is equal to 0, I'll write pressure of reactant at time t is equal to 0, which is P naught. AT was concentration of reactant left at time t. AT was concentration of reactant left at time t. Here we'll write pressure of reactant left at time t, which is P naught minus X. Which is P naught minus X. So my dear students, over here K will be nothing but 2.303 divided by T. This is log of P naught divided by P naught minus X. X is nothing but P naught minus PT. Correct? So you can say it is equal to 2.303 divided by T. It is the log of P naught divided by, this becomes your, wait. X is equal to P naught minus this plus X cancels out. X is guys, here I have done a mistake, sorry. You can say here X is equal to PT minus P naught. Okay, here X was PT minus P naught. So here X is equal to PT minus P naught. Here X is equal to PT minus P naught. So final expression is log of P naught divided by 2 times P naught minus PT. So this is the direct question which is asked in your exam. Get the value of rate constant. Get the value of rate constant in terms of P naught and PT. Get the value of rate constant in terms of P naught and PT. This is the straight question which is asked, right, in your NEET examination. Did you understand how I solved this? P naught 0, 0. P naught minus X, X and X. Now, K in terms of P naught and PT. wrote the expression. Instead of A naught, I wrote P naught. Instead of AT, I wrote pressure of reactant at time t, which was P naught minus X. Then I exchanged X with its actual value, which was PT minus P naught. See, a question was asked in the AIMS examination as well from the same concept. A question was asked in the AIMS examination as well from the same concept. If you look at the question carefully, the reaction is of the type A gives 2 times B plus C. The same process if I follow. Initially, let the pressure due to A is P naught. This would be 0, this would be 0. Now, at time t, if this is P naught minus X, then here it's going to be 2X, this is X, because stoichiometry is 2 and 1. So, total pressure at time t would be this plus this plus this. So, it is going to be P naught minus X plus 2X plus X. So, X got cancelled out. So, I would say X value is nothing but 1 by 2 PT minus P naught. Right? So, my dear students, now it's done almost. K is equal to 2.303 divided by T log of. It's going to be P naught divided by P naught minus X. Now put the value of X here. So 2.303 divided by T log of P naught divided by P naught minus, what is X? X is 1 by 2. This would be P naught minus PT. So this is your final expression, right? Anyways, you can shuffle it a bit. So it is 2.303 divided by T log of, this becomes finally 2 times P naught divided by P naught, divided by 3 P naught minus PT. Divided by 3 P naught minus PT. Do you see any expression like this? 2.303 log of 2.303 divided by T log of 2 P naught divided by 3 P naught minus PT. So this is going to be the final answer of this particular question. Okay? Perfect. Perfect, guys. Perfect. I hope this is all clear. I hope this is all clear. And guys, I think this much is enough for today. I hope all the concepts, whatever concepts I've discussed in the today's session, I hope every single thing is clear, right? The next session is going to be on, if today is Monday, tomorrow is Tuesday will be Ambika ma'am session, Wednesday would be our session. My session will be either on Thursday or Friday. My session would be either on Thursday or Friday. Thursday or Friday would be my session. Okay? Do let me know in the comment section if you like the session. Okay? And I would say the concepts which I gave you here, they are directly going to be asked in your upcoming NEET examination for sure. Right? All right. Perfect. Chalo. I'm taking a leave with this. Okay. I'll see you all in the next session. Take care. I'll share the PPT in the Telegram.